Hello friends, let's have a look at the 2022 May AA commentary. Okay, so as you guys know, in my YouTube channel, I have made 7 hours revision, last minute revision video for attaining 7, okay? And I wanted to confirm what has appeared on the exam, how those video was actually quite beneficial for students who actually did what's for 7 hours before the test, okay? Without further ado, let's get started. So, for me, so the May exam was released, the paper was released in September. So let's talk about one of the questions and make some comments about that, right? So for me, the difficulty was not easy, okay? It was sort of you should not pass sort of a sentiment, okay? I think each question's not like a hard algebra questions, but more of a conceptual problem. So if you didn't know the fundamental of it, it took some time to actually answer it, okay? Without further ado, let's get started. So this is the question number 3 on the paper 1 times on 2. Okay, so I'm not going to go over the entire question. So what I want to go over here is how similar. So remember, I made the last minute revision video for 7 hours, and I wanted to show how those skills were reflected on that question. Okay, please fasten your seatbelt. Let me show you. Okay, this is going to be quite a roller coaster because I was so proud of that contents and how similar actually the paper was. Okay, let's get to it. So, I think this question would have been harder if it was absolute value of x minus 1. Okay, doesn't matter. So you would have thought that maybe multiplying x plus 1, absolute value of x plus 1 is okay because it's positive, sure, but I want to approach this more fundamentally. This is a function of modular domain transformation. So I strongly encourage you to actually be able to solve the inequality by sketching. Okay? So please, I'm not going to solve this one, I'm not solving for x right now, but I want to show you how that question 3 from 2022 May was similar to this. Look at this. Look at this. Do you see that video? This is the one from the 7-hour revision video. But look at that, my friend. Am I talking about a similar example? Thank you very much. I do, right? So I solved this with the sketching and inequality, okay? So you sketch the rational function first, and then, get rid of all the left and make a symmetric from the right-hand side, then solve the inequality by sketching that constant is what you got to do. But let me just confirm. Was it very similar to what I talked about in that 7-hour revision video? Thank you very much. Okay, thank you very much. I don't have to speak. Let my work speak for themselves, okay? Speak for himself. So analytic trigonometry, so sure, some students actually jump to this problem by using the compound angle because they solve with the sum, cosine A plus beta is cocosasa. But that would have been a not so okay method, right? Because you then get to start working with the 2 different ratios such as a cosine and sine. We don't want that. And in fact, 1 over root 2 is a special angle so that you can actually work analytically, right? Because the special angle for the cosine being 1 over root 2, such as pi over 4 or 7 pi over 4 or negative pi over 4 for that matter, right? So am I talking about something similar in that video of the 7-hour revision? Look at that. Look at that. Well, it's not exactly the same for the cosine, but hear me out. This is an analytic approach, isn't it? Because for one, tangent has a special angle, okay? This is just to confirm why that last minute revision video was actually quite nice, okay? Okay, so so I'm not intending to solve it, but just making the substitution, etc. Oh, I was so shocked. I was so shocked to see this. Look at this. This was a question number 6, okay? And then with that graph, you had to find the range. And if I quickly show you the graph of it, it looks like that. So for finding the range, you're supposed to find the stationary point, right, of the maximum minimum, and then you can work on it. Okay, not only finding the x point, you should actually plug it into the y and then see those b and a, right? But look at this. This was the question number 6 to find the range, okay? And look at that, the scenery of look at the one scene from the video. What do you see? Do you see the same function? I'm talking about the same function. Do you see that? Thank you very much, okay? I don't know why, but it's so similar. I mean, it's exactly the same. I did talk about this function because it appeared quite often. And also, this could have been on paper too, because sketching this, if I had a coefficient like 1 over 100, requires you to actually know the domain and use the zoom fit for sketching the y. And not only that, it is very common to know, to talk about the shape and also of its inflection point because the second derivative is quite hideous, okay? So it really puts you in practice mode, okay? But look at that. Is it exactly the same question from the 2022 paper 1 times 2? Yes, it is. You know, it's crazy. It's crazy, I would say. And also, yes, question number 7, integration by substitution involved with the secant and tangent. Well, luckily it gave you the substitution, so you had to work with the substitution, and I believe it will come out as like the u to the power of n minus 1, stuff like that, but it's a definite integration by substitution. You got to change your bounds, don't you? But look at this. On the video, have I talked about that integral? Yes, I did. Right? Talk about the tangent and secant, and we talk about what? The substitution with the secant. OMG, okay? You couldn't miss 7. You could not miss 7, okay? Because in the video, I already talked about it, all right? And integration with the trigonometric identity, oh yeah, so, you know, that one, the ones, it's called recursive cases, and they require a lot of identity with the Pythagorean theorem, right? So easy peasy, lemon squeezy. Oh my God, look at this actually. Yeah, there you go. Right, so that was actually the answer for that problem. Okay, I mean, with tangent and secant, I actually find something similar. And also, look at this question number 9. This question, a lot of students struggle. Look at this. Look at this. I'm not going to solve this, but yeah, proof by contradiction. Suppose it has integer roots, and you had to fall into absurdity. That's what you did. That's what you're supposed to do with this contradiction. You know, reduction to absurdity. Look at this. Cubic polynomial. All right. No integer roots. Look at that. Cubic polynomial, no integer roots. Do you see that? Okay, let me quickly show you the video. Okay, of the 7-hour minute revision video. Look at this. Cubic polynomial has no what? Integer 0. Oh my God, isn't it crazy? Isn't it crazy how that video that I think I posted like 3 weeks before the exam had everything there? Okay, I'm not looking for IB, okay? I wish I could. I will be eventually, hopefully, okay? But look at this. Was that video, 7-hour video for 7, really the path that we had to take? Yes, it was, okay? Thank you very much. Yeah, then, you know, you could actually solve this with something called a rational root test. And if it does have a rational root, then, you know, that it could imply that it has integer root as well, but it didn't, okay? So then we found into the absurdity is what you had to do. And also, yeah, you know, question number 11 involves some sort of expression of a quadratic form where we restrict the domain of x so that it becomes 1-to-1 eventually, and find the expression of the inverse, which involved with the completing the square or the quadratic formula to find the y in terms of x. And in the video, look at that. After having done the rearrangement, rearrange again, use the quadratic formula to find the inverse function. Talk about it. I talked about it. I did talk about it. Okay, that is great. So yeah, you know, so that was also a typical exam question long before, and then it was not 1-to-1, but you had to restrict the x value to make it 1-to-1 and find the expression for the inverse function. Okay, so it did it now. So using the quadratic formula is what we had to do, and then what we did in that 7-hour revision video. Okay, thank you. Welcome. You're welcome. You're more than welcome. Thank you very much. Okay, so okay, so I got so much to talk about for this one. Question number 12. A lot of students actually struggled a lot with this problem, especially for this proving part. Okay, that we were given equilateral triangle. That means the modulus is the same, and then the difference of argument will be pi over 3 because it's 60 degrees for the equilateral triangle, isn't it? And then we had to show this one, and the first one is quite trivial because if you do the product, you know, the argument will just add. But for the complex number, when you add, how can we combine the argument? What's the key on this one? Okay, so for the left-hand side, it will come out as what? You know, same modulus, so I can factorize about r squared, that's no problem. But by using the DMT, you know, this is going to be cis 2 theta 1 plus cis, you know, 2 theta 2 by using the DMT. But what I wanted to do is to put into the single cis form, right? I want to have a look at the one polar form here. So the key was to use a formula that would actually have combined this complex form into one complex number. And you know what? Okay, so that was a diagram. Let me quickly show you this. My friend. Oh, wow. In that video, do I talk about how to formulate the, the sum of a complex number? Very standard, and it's actually appear a lot in many textbooks, but people rarely study this because you can actually prove this either using the trigonometry and sum to product formula or the vector, right? It's essentially just talking about what the diagonal vector of a rhombus, okay? So you can actually derive it using the vector, which is much neater, actually, the way of deriving it. But using that formula would have actually solved this really quickly. Really quickly. Yeah, so this is how we derive it using the sum to product formula. Easy peasy lemon squeezy. Look at this. Look at this. This is a Discord channel on the IB document, right? So look at that. That is my ID here. Look at that. So I talked about what? Oh yeah, there's a multiplication, there's a division, and now the question is for everyone, what's the sum is going to be, right? 3rd of May, my friend. 3rd of May, I talked about it. OMG. Okay, and I did therefore give you the formula sheet, and it would have been very nice. And I do talk about this in the 7-hour revision video as well. Understood? So if I use that proof would have been really neat, because you look at this, that was the problem that we had. And in fact, if you use the formula for finding the modulus and argument, then you can easily do this, and then supposedly the difference, because it was equalized to triangle, was given to be pi over 3, where cosine will just become half, right? Therefore, it cancels out, then it becomes as such. Oh la la. Oh la la, that was actually the same as the product of a complex number. We are adding the argument, then proof is done. And then I think it extends to quadratic form, exactly, which is quite okay because you have seen it a lot. But that proof would have been a lot better if you did watch the video and listen to my advice in the Discord channel. Okay, so I was so proud to see this paper because, it was the first video for 7 hours for 7, and it apparently worked a lot well, don't you think? Don't you agree it was amazing? Thank you so much, okay? But yeah, it's just one more comment here, I'm going to have a look at one of the internal assessment paper from a school in Australia, okay? And they have the exam program like the high school certificate, I think that's what it stands for. And then we're going to have a look at their school internal assessment. And if you look at that, do you see, my friend, does this look very similar to what you just saw? Thank you very much. It is exactly the same. When the modulus is the same, right? And we had to show the product of argument is going to be the same as the twice of the, the argument there. Wow. So here's the thing. Why would this 2004 question also appear in the 2022? That is brilliant. And I will give you a hint. Think about it. What is the fundamental book that every school uses for IB? His or Hess. And where is it from? Australia. Aussie. Okay. And that certificate is from also Australia, okay? So yeah, those video, so I'm not going to talk no more, but yeah, so you could have seen this also first. And some people actually did see this question before they entered the exam. Why? Because they saw the 7 hours for 7 last-minute revision video on my channel, okay? Well, yeah, I was so happy to be of a great help to people, and they personally messaged me, and that was such a fulfilling moment, right? That's what I wanted to do, right? Sublimination. I'm the residue of a Templar Knight 98. Okay, the legend has given spirit to many people, and I'm one of them. Okay, so I intend to talk about some of the legendary exam question in the paper and then elaborate to more interesting ideas so that you can get some idea for the internal assessment. That's what I aim to do, okay? So please stay tuned, and then I will see you around. Thank you for watching. See you next time.